Low Voltage Breaker Course Section 7. Safety First, RCCB, RCD, and GFCI for Shock Protection. Protecting People from Earth Leakage. Welcome to Section 7. Up until now, we have focused on protecting equipment and wiring from massive overload and short-circuit currents. This section is about protecting the most valuable thing, people. The fatal flaw of MCBs. Standard MCBs and MCCBs are blind to the small, subtle current leaks that can cause electric shock. A person can receive a lethal shock from a current as low as 50 to 100 milliamps, which is far too low to trip a 15 amp MCB. Introducing the RCCB RCD. This is where the specialized devices step in. The RCCB, Residual Current Circuit Breaker, also known as an RCD, Residual Current Device. Their sole purpose is to prevent electrocution by detecting tiny leakage currents. The ground fault scenario. A ground fault, or earth leakage, occurs when current finds an unintended path to the earth. For example, when a person touches the metal casing of a faulty appliance or a live wire. The principle of current balance. The RCCB works on a beautiful, simple principle, Kirchhoff's current law. It constantly monitors the current flowing out on the live wire and the current flowing back on the neutral wire. In a healthy circuit, these two values must be equal. Detecting the imbalance. The RCCB uses a toroidal, donut-shaped, core through which both live and neutral wires pass. If a current leaks through a person to the ground, the current flow becomes unbalanced. This imbalance creates a net magnetic field in the core. Tripping at 30 mA. The device is designed with extreme sensitivity. For human protection, the common trip threshold is 30 milliamps, 30 mA. If the imbalance exceeds this tiny value, the sensing coil instantly triggers the trip mechanism. The speed factor. Crucially, the RCCB trips incredibly fast, typically within 20 to 40 milliseconds. This rapid disconnection of power is essential because it prevents the current from flowing through the human body long enough to cause ventricular fibrillation, heart failure. GFCI, the North American equivalent. In North America, you'll encounter the GFCI, ground fault circuit interrupter, often built into an outlet. Functionally, it is the same as an RCCB, but it is typically set to a higher sensitivity of 5 mA and complies with different regional standards. RCCBs don't protect equipment. A key distinction: an RCCB only detects leakage. It does not protect against overload or short circuit. For complete protection, an RCCB must always be used in series with an MCB or a fuse. The all-in-one RCBO. To combine both functions, the RCBO, Residual Current Circuit Breaker with overcurrent protection, was invented. This single device provides both the shock protection of an RCD and the overload short-circuit protection of an MCB. Up next, stopping electrical fires. We have covered shock protection, but what about the invisible fault that causes electrical fires? Next, we will explore the AFCI, arc fault circuit interrupter, and its role in protecting your property from arc faults.